In this video, we'll do some examples of graphing functions. So any function we can represent graphically, as we've talked about. So we're going to plot the function f of x equal negative 1 over 2 x plus 1 on the axis below. So what we're going to do is we're going to make a table of values. And we're going to say we'll pick some x values, and for each of those x values, we're going to calculate what f of x is. Or we're going to plug in x and see what we get. And so we'll pick some values, let's say minus 4, minus 2, 0, 2, and 4. We pick any values we want. These will give us nice answers, so that's why I've chosen those, but you could use negative 3, negative 1, 0, 1, and 3. It's only a sketch of a graph, so they give you just as good of a picture. Negative 1 goes in here, negative 4 goes in. Negative 4 times negative a half is positive 2, plus 1 is 3. This is 3, this is 2, and you should figure out where these answers are coming from. Make sure you can do them. 0, this is 1, 2 is negative 1 plus 1 is 0, and 4 is negative 2 plus 1 is negative 1. So make sure you can get those answers. Negative 4 and 3 is up here. Negative 2 and 2 is here. 0 and 1. 2 and 0, and 4 and minus 1. So there's our graph. We go ahead and draw a line as best we can without a ruler here, and put our arrows on the end to show that the domain and range continue for all real numbers. And that's a graph of this function. Notice x here was to the power of 1, so we expect a linear equation, and that our linear graph, and that's what we got because it's a linear equation. In the second example, we're asked to verify that this graph is in fact given from this function. To do that, we need to pick 3 points to confirm. So we want to pick exact points. So let's say this is a point. That's going to be the point negative 1 comma 5, negative 5. And this looks like an exact point. And that would be the point 0 comma 1. And where do we have another exact point? Down here. Or we could take the vertex, looks like an exact point. Yeah, let's take the vertex instead. So we have lots of options. We take any point. 1 comma 3. The reason I'm saying exact point is because we don't want to have to estimate, because then our calculations might be off and we might be verifying or not. We want to know these points. And so these are at crosses of grid lines, so we know these are exact points. F of x is, of course, this line. The y values, our x values, are this one. Plug them in. If they work, great. If they don't, it's not the right graph. So we want to first put in negative 5 over there, put in negative 1 over here, square it, and plus 3. So you see, here's the substitution. We put in f of x, and we put in x, and really that should be in brackets. We calculate that, we get negative 5. We hope, we're checking, is that equal to? This is negative 1 minus 1 is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8 plus 3. That was quick. Make sure you can do it. And that gives us negative 5 equal negative 5, which is good, which means this point is true. The other way we could write this is say, okay, we want to find f of 0. And we want to make sure it's equal to 1. So we substitute it. Negative 2, 1 minus 1 squared plus 3. Oh, not 1, 0. So that's negative 2 times negative 1 squared plus 3, which is 1. And again, we're good. And that's a good way. So let's do that again. F of 1 is going to be negative 2 times 1 minus 1 squared plus 3. That's 0, so that's all gone, so the answer is 3. So these 3 points are true, so this is now verified. That is the correct graph of that function. And in our final example here, we're going to sketch, again using the table of values, but this time our function's a little bit different. We need to fill out our table of values just like we did before, so plug in negative 3 and get the answer, negative 2, get the answer, etc. I'm going to take advantage of our graphing calculator to do that. So if I type in our function, what I want is to view the table. But before I choose table, I'm going to go table set, because I want my values to start at -3, so I type -3. And I want my table to change by a half. Now the reason I'm choosing a half is because this last point is at 1.5. So I want 0.5 to be how much my table increases by. I go to table, -3 gives me 2. So if -3 gave me 2, I have -2 gave me 8, 0 gives me 2, and now I need to move over and scroll down. 0 gave me 2, 1 gives me 2, and 1.5, well, that gives us 5.375, and 2 gives me 12. I'm just going to write that there just so we can see where our curve is going. So let's put these points. -3, 2. -3, 2 would be right there. Right there. -3, 2. -2, 8. Well, that's way up here. And 0, 2. 0, 2 is here. And 1, 2. 1, 2 is here again. And finally, 1.5, 5.3. Well, that's a little less than 5.5, so about right there. And 212, well, that's going off, so we're way up here somewhere. I'll just put it up here, just to show what our shape is. Now, what we're missing is somewhere in here, there's a minimum point. And what we can do is look at our graph and show what it's going to look like. See, this area in here between 0 and 1, we reach a minimum. Somewhere in here, it's going to come down and then go back up. So now we want to use our points to represent this graph. So we'll try to draw it in one smooth arc here. We'll come up to this, make a loop. We notice it comes through 2, but then it has to turn around and come back up, and then it goes very quickly up there. So it's going to look something like that. So we'll continue with some more examples in the next lesson.